Hello, my name is Lucy Kuncheva, and today I'm going to tell you about Pareto Optimality. Here is the guy called Vilfredo Pareto. He's famous for several things, among which is the Pareto Principle. The Pareto Principle, in his own work, sounds like this. 80% of the wealth in Italy belonged to about 20% of the population. However, I'm sure you have heard about this 80-20 rule in a different context. 20% of the people drink 80% of the beer. And if you think about it, there are many examples in life where this 80-20 principle holds. But today we are not going to talk about that. Today we are going to talk about Pareto Optimality. So here is my example. I'm going to Sofia on a holiday for 2.5 weeks and I want to rent a car. I'm looking at price and I'm looking at miles per gallon. Obviously, I want the cheapest car with the largest miles per gallon so that I don't pay that much. My best choice would be in the top left corner of this graph. The cheaper the better, the larger the miles per gallon, the better. Here are my choices. There are many more. I just picked a few to give you an example of Pareto Optimality. So looking at those choices, Dacia Sandero is the cheapest, Citroën is the most economical one. Which one is the best? Do I take the cheapest? Do I take the most economical one? Or is there another alternative that I can consider? Indeed, if you look at the Hyundai, it seems to be fairly cheap and a lot better than the Dacia, slightly worse than the Citroën. So how do I include the Hyundai in my analysis? In order to do so, let's look at some mathematical formulations. I'm going to call my possible choices alternatives or solutions, A1 to A5. I'm going to call my things that I evaluate them by my criteria, J1 and J2. Clearly, I want to minimize J1, which is the price, and maximize J2, which is the miles per gallon. And here is the maths. If you don't understand the maths, don't you worry. You can get the principle and the idea from the example. But this is for those of you who like maths. I'm going to denote my set of alternatives by A, my set of criteria by J, and I don't limit the number of alternatives or the number of criteria. Here we shall assume that all the criteria are formatted in such a way that the larger, the better. The set of non-dominated alternatives, the alternatives that I'm interested in, contains alternatives A sub I from A, such that for each such alternative, there is no other alternative from that set A, for which all the criteria are better than the criteria on my original alternative AI. So I can't find such an alternative in my set A that is better on all the criteria. That is the idea. Non-dominated alternatives are such that there is no other alternative that would be better on all criteria. So if all the criteria are equal, exactly, then that alternative does not belong to the set of non-dominated alternatives. I need at least one to be strictly better. So if I look at my non-dominated alternative, definitely the Dacia and the Citroen are non-dominated because there is no other car that is better than Dacia on one of the criterion. No other car that is better than Citroen on the other criterion. How about the Renault? If I look at the Renault, Dacia is better on price, Citroen is better on mileage. So is Renault a non-dominated alternative? No, it is not, because I can find another solution, another alternative, which is the Hyundai, which is better than the Renault on both criteria. And it is enough to find one alternative that is better than both criteria to declare then Renault is not in my set of interest, set of non-dominated alternatives. How about the Hyundai? Dacia is better on price, Citroen is better on mileage, but there is no other car that is better on both criteria simultaneously than the Hyundai. Hence, Hyundai goes into my set of non-dominated alternatives. For the Skoda, I will have, again, those three cars, Hyundai and Renault and Dacia. They dominate the Skoda on both criteria, and the Citroen dominates the Skoda on the mileage criterion. So Skoda Octavia is dominated by other alternatives. I can't find another alternative that is I can find alternatives that are better than Skoda on both criteria, which means that Skoda is not in my set of non-dominated alternatives. So non-dominated alternatives are Dacia, Hyundai, and Citroen. And I can draw a graph line that joins all my non-dominated alternatives, and that graph is called the Pareto front, or sometimes the Pareto frontier. Here is an example of a Pareto frontier or Pareto front for a set of points, random points generated in a sphere, assuming larger is better on all three axes. And you can see those little black points that stick out. These are my non-dominated alternatives that define the Pareto front. Where can I use Pareto analysis? Suppose that I want to learn a new scientific discipline. I'm pretty new to that, so I want to know where to start, which papers to read. There are so many papers these days that I can drown in them. So I want papers that are both pretty new and pretty well cited. But those two criteria are contradictory. So what I can do instead is collect a lot of papers and look at their bibliometrics and plot the graph and calculate the Pareto front and see which papers are on the Pareto front and start with those. Those will be the compromise between the highest citation and the year of publication. Well, what is the conclusion of the whole thing? Definitely, I will not be hiring a car on my holiday. Thank you for watching.